In this video, we'll look at graphs of inverse functions. So first of all, remember that inverse functions swap the domain and the range. So the x values of the original function become the y values of the inverse function, and the y values of the original function become the x values of the inverse function. So that will affect how the graph looks. The other thing to remember is to check whether or not two functions are inverses. We know that f of g of x has to equal x, and g of f of x has to equal x. So what we're trying to do is we're trying to check whether or not this is true, given the two functions. So we're given f of x equals the cube root of x minus 4 quantity over 5, and g of x equals 5x cubed plus 4. So let's go ahead and do f of g of x. F of g of x will be the cube root. Now I'm going to plug g of x in where I see the x here. So I'm going to have 5x cubed plus 4, and then minus 4 is part of the f function, so minus 4 over 5, and I want to go ahead and simplify that. So the 4 minus 4 cancel each other out, so I end up with the cube root of 5x cubed over 5. 5 over 5 becomes a 1, and so I have the cube root of x cubed, and a cube root and a cube undo each other, and so that would just give me an x. So that one checks out. Now I have to check g of f of x. So I'm going to go the other way and plug f of x into my g function. So my g function is 5x cubed, but instead of the x, I'm going to write the f function, which is the cube root of x minus 4 over 5. And in my g function, that variable is cubed, so I'm going to put a cube up here, and then plus 4. So I plugged the f function into the variable in my g function. And now I want to simplify. So I have 5 out front. The cube root and the cube undo each other. And so this would just become, the cube root is going to drop off and the cube will drop off. So I'll have 5 parentheses, x minus 4 over 5. And then the plus 4 there on the outside. Now here, 5 over 5 cancels and leaves me with a 1. So I get x minus 4 plus 4. Negative 4 plus 4 cancels into a 0. And so I end up with just x. So that one checks out. F of g of x is equal to x. And g of f of x is equal to x. And so we would say, yes, f and g are inverses. So that's how you check whether two functions are inverses. Now we're asked to graph the functions on the standard grid. Standard grid is x going from negative 10 to 10 and y going from negative 10 to 10. So let me pull up my graphing calculator here. And I have my standard grid here. X is going from -10 to +10. Y is going from -10 to +10. And you can adjust that using the wrench in desmos.com/calculator. You can adjust your window here. So I'm going to enter my two functions. I'll enter them as y equals. So I'll do y equals, if I want to get the cube root, I can go ahead and get the keyboard here and go to functions and then scroll down till I see the cube root. I'll select the nth root here and put a 3 on the outside. So there's my cube root. And then I will do parentheses x minus 4 divided by 5. And then for my second function, I'll do y equals 5x cubed plus 4. All right, so I've got my two graphs here. And the first one is the cube root. The second one is the cubic. Now, what do you notice about these two graphs? Let me graph a third part. Let me graph the line y equals x. So if I look at the graph of the function, the cubic function and the cube root function, if I folded my paper on the line y equals x, then those two graphs of the function and the inverse would be lying right on top of each other. We call this symmetry, and it's symmetric over the line y equals x. So anytime you have a function and its inverse, the graphs are going to be symmetric over the line y equals x. So let me come back to here, and I'll go ahead and draw in that y equals x line. So that we can see it here. Okay, so here's the line y equals x. And we would say the graphs of f of x and g of x are symmetric. The graphs of f of x and g of x are symmetric over the line y equals x. Now, if you think about inverses, the domain and range switching, this makes a lot of sense because every ordered pair AB on our original function will become the ordered pair BA on the inverse function. So this is because the x and y values switch. So let's take this idea and go one step further. And if we are just given the graph of a function, can we find the graph of its inverse? So let's look at an example of that. Here we have the graph of function f, and we want to graph f inverse. And this should say the inverse of f, not then inverse of f. So the inverse of f. So remember that the x and y values switch. Okay, so f is in black here. So let me actually grab a different color to do the inverse. And let's look at the ordered pairs here. So on F, I have this ordered pair right here. On F, I have the ordered pair 5, -3. So for F inverse, that's going to become the ordered pair -3, 5. So I'm going to go ahead and graph that. So -3, +5 is right up here. And then I'm going to look at the corner point right here. So on F, I have the point 0, -6. So on F inverse, I'm going to have the point -6, 0. So let me go ahead and label those. So this is -3, +5. Here's the point -6, 0. And maybe I can move that over a little so it won't be in the way when I graph it. And then this last point on F is -8, -7. So X is -8, Y is -7. And so on the inverse, I'll have the point -7, -8. So here's -7. I want to go down to -8 right here. So here's the point -7, -8. Now, because these parts of F are connected with straight lines, I can actually do a similar thing with the inverse. So let me just grab some straight line segments here. And I'm going to go ahead and connect those points. So I'm going to start at the -7, -8, connect to the -6, 0 in a straight line. And then I'll go from there, connect in a straight line to the -3, 5 point. And you can see that those two graphs, F and F inverse, are symmetric over the line y equals x. So we have that symmetry. There's my F inverse function right there. And you can see that they're a mirror image of each other over the line y equals x.